So thank you everyone for coming to this track. The presenter for this topic is Chris Alexander. Chris is a former Naval Flight Officer. Today he's an Agile coach, Scrum Master, Scrum Studies Certified Trainer, web developer, and co-founder of AGLX Consulting, which is based in Seattle. And he will be sharing with us a scalable framework he developed which can be used to improve the risk management system in software and hardware development. And before he starts, I'd like to request that you guys turn your cell phones to either silent or vibrate mode so that the speaker doesn't get interrupted during the presentation. And there should be plenty of time at the end for Q&A. Thank you.
Thanks. Morning, everyone. Can everyone hear me with the lapel mic on? Hear me in the back all right? Awesome. Thank you. So, good morning. We're going to talk about risk management, software, and hardware development this morning. It's a little bit different, I think, than what we traditionally think of risk management in terms of like project risk and deliverable risk and things like that. What I'm really talking about is building a system and a framework through which you can actually build a resilient organization, a resilient company, by using risk management as a tool to feed back into the processes that drive your development practices in your software engineering org. So we'll talk about a little bit about myself. As mentioned, this is really the world that I come from. I was a naval flight officer in a Rio Goose, for those of you who are familiar with the movie Top Gun. I did that for about just shy of 7 years. So I did an operational tour, and I also was an instructor. And part of my job as an instructor was teaching what we in the Navy call operational risk management, which is kind of what this framework is built upon. We face a lot of risk flying and operating from carriers at sea, even from bases at land operating in combat. And we had to get really good at analyzing, managing risk, of course, makes sense. But we also had to really learn about how to use that to improve our system. So we're not making the same mistakes twice. Everybody talks about lessons learned, often better known as lessons forgotten, right? Because we fail to learn them, we have to relearn them. And that's true in every organization. It was certainly true in the Navy. And it was a constant battle. So we developed operational risk management in order to help us do that. And the good news about it is it's based on the way that we manage risk every day in our lives. You wake up in the morning, you look outside, you look at the weather, you check the temperature. If you're going on a trip, you're going to drive somewhere, you think about how long are we going to drive, where are we going to stop, what's that going to look like. All of those things are actually risk management activities. You're thinking about the goal you're trying to achieve, the things that are going to stop you from being able to do it, and you're making decisions about what kind of risk you're willing to accept. Right? If I'm going to go on a 2-day climbing expedition, I'm a rock climber also, by the way, and the weather's not looking good, I really have to evaluate, is it worth being soggy for 2 days and kind of maybe not getting a whole lot of climbing in, or could I do something better with my time? That's a risk management process. And that's what we'll be going a little bit further through. So bringing that into our world, right, because it's clear military operations are extremely dangerous and we're always risk averse. In our world here in software and hardware engineering, risk affects us in a lot of ways. And we think, well, we've been doing this a long time, right? We should have this figured out. It shouldn't be that hard, right? Everybody's professional here, most people. I'm, by the way, not really an engineer, so I defer to the expertise in the room. I can't really tell you how to do your job because I've never done it. But what I have seen at both startups and enterprise is that people don't really think risk is going to impact them, and they can't really do anything about it. And so they often dismiss it, forget about it, don't worry about it, don't take any action, right? And there's a reason for that. We'll get to it. But I was thinking about what are a couple of examples of kind of larger failures that have affected us that people may have seen or known about. This is one. Everybody remember this? The launch of Healthcaregov. A very ambitious project following on the passage of the Affordable Care Act that basically crashed as soon as it was deployed. And if you read this, there's a lot of studies that were done after this. There's a congressional inquiry, right? The Government Accountability Office did a whole study to figure out what went wrong. And what did they find? They found that people failed to appropriately identify, manage, and mitigate risks through the project, right? And this is like we're launching the US's national healthcare system. You'd think people were focusing on it, but they weren't. They didn't. They found systematically throughout the entire project, people just weren't managing and talking about the risks involved. It was get her done. Just get her done. They didn't get her done. Another example that hits close to home for me personally, the Office of Personnel Management. Has anyone heard of this failure? It was a hack. You hear that? So the Office of Personnel Management, I've had a top secret security clearance for 19 years. When you fill those out, you have to give every conceivable piece of data you've ever had. I mean, every place you've lived, every friend you've ever known, every acquaintance, every girlfriend, every piece of data about your family. And when I started in the military, you wrote that all out on a very long, thick document. And you sent that in. That was stored in a database. Later on, I noticed, hey, now I'm doing my security clearance renewal. I just go through this web portal. This is really cool. I don't have to write this stuff on paper anymore. Technology, yay. The government's actually catching up. Not so fast. Not so fast, right? The Office of Personnel Management was hacked into and lost the security information for 21 million people. So anybody out there with access to my data right now can literally be me. There's no question you could ask them that they couldn't answer. They know everything that I know effectively. And it was all because risk management. They were trying to integrate that really old database that I mentioned. They were trying to integrate that really old database with this brand new front-end web technology. And naturally, that left a lot of vulnerabilities that were able to be exploited once someone gained credentials to be able to access the system. And this was known. And they didn't do anything about it. So risk management, again, would it have prevented that? I won't go that far. But I do know that not having used risk management definitely enabled. So, what are we going to talk about today? Good news, introduction, already done. How many other things? We're going to talk about shared mental models. It's important. It's one of the key things in performance. We're also going to talk about defense in depth, a concept most people here are already familiar with. I talked to a couple of security engineers last night, and they were like, oh yeah, of course, got it. Talk about what causes errors, particularly in software development. And we'll talk about risk life cycles. And that goes more into building processes that we can use at every level of the organization, at team level, at department level, at company level, to be able to manage risk. And lastly, we'll talk about what brings it all together, which is continuous improvement. That's really the most important thing. And root cause analysis goes into that. So I mentioned shared mental models. Anybody heard of that term before? Anybody familiar with it? All right, good. Couple of people, all right. So shared mental models, there's a lot of research in this. We're going to go through each one of these in detail. And I've highlighted, no, I'm just kidding. There's a lot of research in industrial organizational psychology about the effect of shared mental models. And you actually are already using these in a lot of places in the world and in your day-to-day jobs. So a shared mental model is simply a shared conception of the way that we're going to do things together, the way we're going to work together. Right? If you've ever worked in a really good, high-performing team, it's functioned so well because you've had a group of individuals who had a shared mental model about how you're going to work, both at the process level and at the teamwork level. Right? So what process are we going to use? Are we going to use Scrum, Lean, Waterfall? And how are we going to communicate? What sort of behaviors are acceptable? How can we relate to each other and work together effectively? Those are shared mental models. And having those shared mental models is the key to performance and effectiveness at every level, at the team level, department, organization, company. Right? The more closely aligned you can be with the way that you carry out work and the way you conceive of work, A shared vocabulary is also part of this, critical, using the same terminology. It enables you to perform effectively, especially under stress, especially under challenging conditions. In the Navy, coming back to my world, I could walk into any other squadron and I could talk in the same language and interact with the people in that squadron and carry out missions with them because we all had the same model. We had a shared vocabulary. We had a shared understanding about the terms we were using and what they meant. And that enabled us to not worry about that and have those discussions and move on to execution. So one of the things I'd like you to leave here today with, is the idea that we need to build a shared mental model about how we deal with risk, right? Often we get focused on fix the bug, right? Get the server back online. Make sure we hit the deadline, right? And that's great, we need to do that. But we're getting pretty good at doing that. And what we need is a way that we can talk about risk and share it throughout the organization in order to help us improve altogether. Shared mental models is one of the keys. So has anybody ever heard of James Reason and the Swiss cheese model? Anybody? Ah, okay, cool. So this was a model that we used in aviation. It goes back to defense in depth. Anybody not familiar with the concept of defense in depth? Basically, okay, a couple of people. So the idea of defense in depth is, let's think about medieval ages, right? I'm going to build a keep. And around the keep, I'm going to build a courtyard. And around the courtyard, I'll have a wall. You know, it'd be great, after that wall, I like to see people coming, so I'll build another courtyard. And then I'll have another wall. And around that wall, I'll have a moat. So there are these layers that have to be circumvented or overcome in order for somebody to get to me. But it also works the other way around, right? It also works in the sense that if we're trying to build a software quality system, I want layers, I want depth to the way that I'm trying to find errors or defects in my code base. I want to trap them. And the more layers I have and the more checks I have, the more sure I am to be able to do that. So that's defense in depth. And James Reason, who is an accident investigator in aerospace, as well as a couple of other industries, kind of put this together. He said, when you get a defect that escapes, when you have an incident occur, it's because you think of all those layers as slices of Swiss cheese. And the holes have lined up, right? Each layer is supposed to trap certain defects, certain errors, certain risks, stop them from getting out. And when all the holes line up, that's when you have a problem. That's when something gets through. That's also where the opportunity exists to improve your system. Find those holes and plug them up. So I'm going to show you the model that we kind of developed at the company I work for at the moment, Cumulo, up in Seattle. We're a data-aware scale-out NAS solution, so big clusters of databases that you can kind of scale out to petabyte size. It's a really complex problem. It's a complex space for us because when we sell a system to a client or a customer and they start using it, we don't really know what they're going to do with it. And they find really interesting things that we couldn't find through our testing and that we didn't even know was possible. One of our customers called us and said, we're having a problem with your cluster. We said, great, what's going on? Tell us about it. They said, well, we've got like 200 something clients attached to it and they're hitting it with all these IOPS, and we were like, wow, never ever have we thought somebody would use that much throughput and hit our cluster that hard. So it found really interesting behavior that we hadn't foreseen. So this is the model that we kind of built to help us think about our system. So again, shared mental models, right? It's the Swiss cheese. We wanted to think about what are our layers? What do they look like? What goes into them? And you have latent and active components to all your layers. Latent are things that are characteristics of the system that you're using, like the language of your code base, right? The architecture, the infrastructure, whatever. In our case, we're in primarily Linux. So that's a latent factor, right? Every language is good at some things, bad at some things. Different servers are good at some things, bad at others. So those are characteristics that you need to be aware of. Then there's also active blockers, things that you're actively doing to try to find or suppress errors. Things like your programming practices, any of your build systems, test utilities, all that stuff. Those are active things that you're doing to try to prevent risk or mitigate it. So this is kind of the way that we conceive of it, where we are. Again, the value in this is not this model. The value in this is that we created a shared model that we could use to think about our work and to talk about it and to conceive of it. So in your domain, your challenge is to go back and build that model. And it'll change over time, and it can, and it should. But going back and having a model through which you can talk to people throughout your organization about what you're doing and how it can be improved. Okay, so we'll move on real quickly, talk a little bit about error causality. And causality is important because it leads us down the path of improvement, and this is specifically on the side of when we're developing. So we're in the development phase, we're not in the production phase. There's two primary types of errors that we boil it all down. Right? To our development practices, there's two areas that we find. You have skill-based errors, and you have knowledge-based errors. The skill-based errors fall out into two flavors, errors of commission, errors of omission. And a skill-based error is any time that I make a mistake that arises from a previously learned behavior. So I've learned something in my past, I've done it, I should know it, but I make a mistake, and that's where the differentiation comes in. An error of commission is I do the wrong thing. So I know I'm supposed to do the thing, but I do the wrong thing. Whereas a skill-based error of omission is I simply failed to do it. I forgot. Yeah, I know I should have done that, but I didn't. And the next type of error is the knowledge-based error. So that's simply I didn't know. I didn't know. So haven't learned that before. You hired me to write a program in Java, but I never learned Java. Knowledge-based error. I've got a very simple, don't make fun of my coding skills, example to show you. So if you think of it as we create a function, right? The function is supposed to call a variable, and it should return it. We can understand that. Even I can understand this. Put a bunch of code in, and then there's my call. So that's a skill-based error of commission, right? I should have called the x variable, but I called y, right? And omission is the other. I just didn't put it in, forgot to do it. So that kind of covers where the errors come from when we're developing, putting stuff together. On the other side of it, think about the risk life cycle. And this can also apply in the development realm, but we engineered this specifically in our domain at Cumulo to deal with things that we find in production. Things like that large cluster that was getting used in a way we hadn't foreseen and created some anomalies. What we want to do is make sure that we have ways to discover risk. We want intake avenues. Normally that's going to be like customer support, right? Or if you have, our organization has engineers specifically dedicated to deal with customer issues when they occur, like right at the moment. So however you can conceive of a way to make sure you're intaking risk, have an avenue that you can talk about it, whether that's at the individual team level, right? If you're in a development team, how do we bring this up? Who do we talk to? Talk to each other, talk to a program manager, talk to my director. We need a way to bring that stuff in. We heard about being leaders today, right? So we also have to ask for that. We have to say, hey, we need a way to bring this in. We need a way to catalog this and talk about it. Oh, sorry. So the next part is the analysis. How do we analyze? What do we do? Two primary things. Probability, severity. It's the next slide. Once we've analyzed the risk and we have a feeling for how significant it is, how it might impact us, then we can move on to making a decision. What do we need to do? We can't deal with every risk out there, right? It's unrealistic. Some are not important enough or likely enough to warrant applying resources and time against them. So we have to make a decision. But the key is we know about it and we make a decision, a purposeful, mindful decision. We're not going to do that. And then we track that. It goes back to the lessons learned. So when we hit it again, somebody says, oh, this is new. No, it isn't. It's not new. And then lastly, the improvement. How do we improve our systems? So this is a model we use, again, at Cumulo that we built, taking us through how do we think of probability and severity. So we'll start with probability. Some people may prefer to use like a percentage-based, like 90% likely to occur, 50%, 10%. You might have another, there's lots of smart people who are much better at math than I am, so you might have a better mathematical model for that. We like using words because it's something we can talk to, whether we're talking to engineers or directors, business people. We just have we want a common language. That's what we want to have. People understand words. So we use words like definite, probable, possible, unlikely, won't. Won't means less than 1% chance. That's the model that we came up with. If you work in an organization full of engineers, maybe you can come up with a better mathematically reflective model. Then we have severity. If the bug or risk is actualized, how big of an impact will it have? It's also important how you define impact. How big of an impact will you have to the customer? How big of an impact will it have to us? Like, that's a term that needs to be clear as well. So we put it for us because we're totally focused on our customers. It's all customer. How much of a problem will this be for a customer? Blocker, will it be critical? Is it just a minor thing, insignificant? And from that, we have a matrix. And it helps us conceive of risk. So we think about, where does this risk need to go? We use it to generate what we call a risk assessment code. And that risk assessment code is just a quick way to go through and decide, OK, we need to do something about this right now. Right? It's pretty obvious. If it's a blocker for our customers and it's absolutely going to hit every single time anybody starts their cluster, we need to deal with it. We have to do something about it right now. As you move down and to the right in the scale, it becomes a little less obvious. And that's where we really have to have that shared mental model about what we're going to do, that shared language. How do we deal with this? Where are we going to feed this back into our systems? Based on that, we move on to the risk decision, right? What are we going to do? There's three things. And this is the same in basic project risk management, right? When we surface a risk, we decide what we're going to do about it. We're either going to accept it, do nothing, write it down, log it, remember it. But we've done that purposefully, mindfully, so we know about it. We're going to deny it. We're going to mitigate it. So we're going to decide what actions we're going to take. We're going to make a plan, and we're going to execute it. Or we're going to defer. Defer is the third one. Deferring means we're not sure at the moment what we should do. Let's put it off for a time box, a week, 2 weeks, and then we'll move on, and we'll make that decision at that point. You can't indefinitely defer. That's also an anti-pattern, and I have seen that. So coming back to our model, we've now got shared mental models for our system, how our system looks, what we could talk about, what's important to us in our world. And we also have a shared mental model for looking at risk and analyzing it. And now what we're going to do with all of this is improve our system. And this is really where we get to the value of having these shared mental models and putting the work up front. When I introduced this at Cumulo, it was a little challenging. There were a lot of questions. People weren't thinking like this at all. And it took some effort and some dialogue to get people thinking this way. That was in November of last year. Now, it's a part of our vocabulary. People just talk that way. We don't really actually have to focus on having this process because people have internalized it. They've turned it into muscle memory, so it just happens. And it happens the same way every time. Continuous improvement is important because this is what's going to make our systems resilient based on what we learn as we go forward. So we talked about the need to have that intake. How do we intake it? It'll be obvious when you're doing regular software development, right? An engineer will submit work into a submit queue, and the build system will run, and it'll fail. Great. We get a bug. That's an intake process by itself. So that's one way. We also need a way to capture risks from projects and from customers. Once we have that, we're going to root cause it. Root cause is another art, not so much a science. A lot of people stop root cause at the surface, and they don't go deep enough. Anybody heard of the 5 whys or the 9 whys? Okay, so that is a root cause methodology. Like, Go down until you get to the lowest thing. The model I use, there are 7. We'll cut to this really quick. So we always focus on getting down to 1 of 7 causes. And sometimes there might be a couple of contributors. That's OK. Communication, that's obvious, right? We failed to communicate. We failed to share the appropriate and necessary information to enable people to do their job. Often a contributing factor. Knowledge. So we talked about, I have a knowledge-based error, right? Like, I didn't know this thing. So knowledge might be a root cause. Experience. We ask somebody to do something that they just don't have the experience to do. Or we put someone in a position to fail without giving them the proper support. So that's an experience problem. Again, may point to other things. Discipline. Were we lazy? Were we lazy? It happens. People get in a rush. People have things going on in their lives. We call those human factors. They get a little lazy. They slack off a little bit. And then we get an issue. It's OK. It happens. We just don't want it to happen the same way every time. Teamwork. Did we fail to work together in the right way, either as a team or as an organization or as a company? Did we fail to provide teams with the necessary support to be able to achieve success? Was it an organizational problem? This happens a lot. As an organization, do we have a structure that inhibits communication? Are we not able to talk to people we need to talk to when we need to talk to them in order to enable us to be successful? There are lots of things that can happen at the organizational level that actually cause problems or prevent us from fixing things. And finally, leadership. Unfortunately, when leaders fail to provide clear direction, when they fail to be there to make decisions, when they fail to do those sorts of things, they can be a root cause. Leadership can be a root cause. Got to be strong to go up to a leader and say, this is your fault. I hope you have the kind of leader that you could. In the military, that was part of our discipline. I could go to my boss, to my squadron CO, to the commander of my air group anytime and go, you screwed this up. This was your fault. And as aviators, we take that on. We take it seriously. Just like anybody who worked for me could come to me and say, this is your fault. Got it. What can I do to make it right? So we've kind of gone through the intake. We've root caused. What caused this? Now we're going to figure out, OK, looking back at that layer, looking back at that Swiss cheese model, where can we fix this? What do we need to do? What can we make better? And usually there's going to be 2 or 3 places. We want to target the areas that will give us the biggest bang for our buck, the most improvement for the least effort. We need to decide. So that's kind of that decision-making point. What are we going to do? We can't fix everything. What can we fix? How can we improve? How can we change? Then we're going to implement those changes. And this is the part that always gets left off at the end. We're going to monitor them. We have to monitor the changes that we make in our system to make sure that the things we're changing actually have an impact, actually fix the problem, actually change the system. We just did this in an interesting way at Cumulo by changing our hiring practices based on the fact that we had a couple of problems in the knowledge realm with new hires. And part of our root cause analysis of that problem led us down the path that we need to really think about how we're hiring and what our criteria are and what we're looking for and how we're doing hiring interviews. And we've now changed our process. It's actually the 3rd time we've changed it, but we're learning and we're trying it, and then we're monitoring. So that brings us back to the framework, the shared mental model. Where can we plug up those holes? The other way to build this is kind of in a bottom to top way. So you can think about your system in terms of the latent stuff at the bottom and the active stuff at the top, and target where to make your improvements based on that. Ideally, you want to target the lowest, earliest point. For us, in the last example I just gave, that was our recruiting. Right? Recruiting was a very fundamental cause. It was a very fundamental place to start changing and improving our system for the type of hiring we do and the types of engineers we brought in. That can make a big difference. It can also be a big difference in how you onboard those engineers, how you train them, how you get them up to speed. So leaving here today, I want to leave you with those 2 takeaways. Number 1, make sure you have a system, whatever it looks like, that builds a shared mental model in your organization. That everyone can speak the same language and have the same picture, have the same situational awareness, because that is the number 1 driver for performance and effectiveness. Number 2, risk management knowledge is actually out there. But what I found to be kind of lacking is the understanding of how to take that and then reapply it into your system to improve your system and make it more robust and more resilient in a purposeful way. And the resiliency is the benefit. We can fix the bugs. We can deal with the customer issues. Right? That's not the hard part. The hard part is how do we make our company, our teams, our organization, our infrastructure, how do we make that better based on the things that we're learning? Right? That's 30 minutes. I'm happy to take any questions anybody has now, or contact info is here. This is also published in the proceedings. The full paper is a little bit more detailed than my 30-minute chat. So you're feel free to reach out to me anytime. Anybody have any questions? Sure. Go ahead, sir. You were first.
So, in terms of your company, when do you, in terms of your SDLC, when do you think about risk? At what point? At the beginning, the middle, the end of the software life cycle?
Go ahead.
I don't know.
Yeah.
That's a question.
The answer is yes.
All of the above.
All of the above.
Which is the most important?
All of the above. Well, so I'll give you my take, and certainly everybody has opinions on this. It depends on what type of risk you're trying to address, right? Project risk, and what I got really upset at my company at the beginning in my company when I showed up, people were going. I told this anecdote last night. People were saying, we didn't get that out in time. Two engineers were out on vacation again, and I'm like, how is that surprising? Like, why did you not talk about that during planning when we were planning all this? Oh yeah, I guess we could have, right? That's a basic failure of a risk management system, right? Where nobody was thinking that way. So that helps you mitigate like project type risk. Like, the basic risk, create the risk register. Like, what are all the things that are gonna mess us up as we're going forward? You know, we're planning this new feature we're gonna build. What do we need to worry about? But eventually, as you build that repetition, that muscle memory in the risk system, you get to the point of that becomes automatic and built in. And it becomes more important to be responsive to risks that you find during development or that you find, especially in our domain, in the field. Because we literally have people using our systems in ways that we hadn't thought of. So we learn. We have to be able to learn from our customers because they are providing us the most interesting data. So that becomes especially critical in like that sort of environment. Go ahead.
Seems like that mental model of the Swiss cheese and layers is more dynamic than maybe you put up there. Like the holes move around, realign, more holes show up. And so how do you adapt to a changing risk environment so that you can deal with things? To quote Rumsfeld or whoever it was, we don't know what it is we don't know.
Yeah, the unknown unknowns.
Or the unknown unknowns.
Yeah, absolutely. And it's also, there's a great book by Nassim Taleb, if anybody hasn't read it, called The Black Swan. And it's all about this. It's about realizing that looking backwards and looking at what you know, you're going to close those holes up really quickly. But there's this whole other side of the rest of your life where there are a bunch of unknown events that are going to impact you. And the key to have, that's why you build those shared mental models, and that's why you build that, because that supports you when you go into the unknown. So we spend a lot of time in the military training and talking and making sure we're doing all these things the right way, but it's because we know that as soon as something happens, it's going to be chaos. And having those foundations are what support you as you step into the chaos and you start making forward progress. And it's all about learning. It's 100% learning. It's, we're going to try this. That didn't work. Okay, what did we learn? What can we do now? And what you're really doing is discovering the holes in the Swiss cheese. You're discovering the things that you haven't seen. You didn't know that that could happen. We had no idea. And as you close up those holes, you'll find new ones. So it is actually very dynamic. And even our model has changed 2 or 3 times because we said, well, we added a couple of things, took a couple of things out, and I think it should change. None of this is static. We don't live in a static world. Shepard?
So like, how do we like assess the continuous improvement? Like, we like do the root cause analysis and everything, but like, what would be the factors we can use to assess the improvement?
Well, the most basic factor is having an understanding of what you're trying to fix and having a clear understanding of what that fix will look like if it works. And then monitoring it to make sure that it actually does that. So in the example I gave, I'll just keep using it because it's apropos, the hiring and recruiting practices. If we see that the engineers we start bringing in and onboarding are more closely aligned with what we want in a candidate, then we know that that's worked somewhat. So we know that that's an improvement. So always trying to identify what is it I'm trying to do, what will good look like, and then did we get to good? Basic cycle.
So we should have the expectations for each layer, right? Because for each layer.
For each improvement, maybe. Yeah, for each improvement, definitely have, yeah, every time you're going to improve something, it's an inspect and adapt. So we're going to try this. This is what we think. Did it work? Yes or no? Where do we go next? Okay. Yeah? Yeah.
I just had kind of a setting up question. In my company, the business is kind of disconnected from IT.
Mhm.
And so you're building a shared vision is part of our biggest problem. So I was trying to think of ways. So are you talking about like an ideology, maybe a glossary of terms, or an actual physical model to get everybody on the same page, or all of the above?
All of the above. But, so it depends. It always depends, right? It depends on your environment and figuring out what will work best to achieve the best results, right? In our environment, we are very closely aligned with the business. So we built that model with them. We sat down and said, let's talk about this. And they were the ones who actually said, sitting in a room full of engineers, everybody said, well, I want all of the probability stuff to be, 10%, 20%, 50%, and a couple of our business guys said, well, okay, I got it. I understand percentages, but that doesn't tell me anything. So can we change that into a word? And especially if you think about what they're going to have to do, they're going to have to go brief the executives. So the executives, the first thing they're going to say, well, let's get 25% chance. Well, what does that mean? Like, what does 25% look like? But if I say definitely, then you know. If I say probably, how probably? Greater or less than 50%.
And then you assign, for those engineers, you assign the percentages to the words, but for the executives, the words kind of fill in the blank.
Yes.
Got it.
Yeah.
Thank you.
Sure. Any other questions? Yeah.
Can we talk more about analyzing the backlog compared to the risk level and value? So when you go deeper into your paper, you talk about assessing everything kind of that story journey level.
Mhm.
But it's a pretty heavy process, and so how do you pick the right level of process based on risk and value?
Well, it depends on, in our environment, we're almost 100% Scrum. So it was very hard at first, and it was very process intensive and heavy and painful for all of us to go through that, to take the time to say, okay, we have a backlog, we've spent time developing it, grooming it, building it, we're ready. And we do that in kind of an ongoing way. So we only build enough backlog to get us to the next iteration. So we're not wasting time. So we only do enough risk analysis to, at the beginning of a project, to look all the way to the end and say, are there any big things that will trip us up? Are there any big things that we have to deal with right now? And if they're not, then we only deal with the risks in the near term, and we just risk adjust the backlog like you should typically be doing in a Scrum environment. Prioritizing, then risk adjusting, so you're tackling the biggest, scariest areas first. If there are long-term risks, then that becomes also a discussion about what do we do? How do we deal with this right now? Do we need to deal with it right now? Can we delay that decision? Last responsible moment type of thing. It looks a little different every time we do it. But the teams have gotten, again, they've gotten kind of good at it. So it's starting to become a muscle memory thing. And that's the value. It's always painful when you're learning a new skill and doing it first. It gets really easy once you've been doing it for a while. So it becomes much less of a process-intensive, painful experience for all of us who don't want to sit in a room for 2 hours.
And can I follow on with that? So then with your risk assessment matrix, if it's like a level 5, is the teacher going to say, I don't care, and not spend any time on it?
We draw, so in the risk assessment code, we have 1 through 5. We draw kind of a line at 2. So if it's a 1 or a 2, it's something that we need to go talk to probably a director about and say, hey, this is a big deal. If it's a 3 or a 4 or a 5, it's something that the team can decide for themselves. Like, what should we do? Should we do anything? If it's a 4 or a 5, oftentimes we won't do anything. We'll accept it and just keep going. If it's a 5, almost definitely every time. But definitely the big issues, especially 1 and 2, we need to do something with. And that decision needs to get made at the appropriate level, which is normally for us, not our team. So we take it up and we let other people make that decision. Good. Other questions?
So in your model, whether like the risk assessment code changes, or like if it only changes, like what would be the frequency where you reassess the codes?
Mhm. Yeah, I mean, you could reassess. You could redraw the model as you need for your environment. That's just what we came up with for us, and that made the most sense. Again, in a discussion between the engineers and the business people, like, where do we feel we need to cut lines? Where do we? What is for us? Number 1 is strategic risk. So something that could literally, like, one of our promises to our customers is we will never lose data. So obviously, if we find a defect that could cause data corruption, that's a strategic risk. It's one of our core values. We won't lose data. So those decisions get brought up. But that arrangement and those lines were agreed by everybody. And they could change, sure. I don't know that those codes ever will for us, but that may not make sense in every environment. Does that answer your question?
Yeah, okay, sure. So basically, like it changes like in the situations, like maybe in our environment, it may change,
Mhm.
like where the core values are like constant.
Yeah, sure. Okay, sir.
Going back to the Swiss cheese model, have you considered just focusing your energies on addressing the holes in 1 or 2 of those types of issues, so that stuff doesn't get through?
Yeah, absolutely. The problem is as the gentleman over here asked earlier, is you have emergence. And that's why we want to build resiliency, because you can close up all the holes that you know about. The ones that will always get you are the ones you don't know about until something flies through them. So that's why the improvement is so important, because you will get a pretty solid system based on everything you know. But then you'll find things you didn't know, and that's what will bite you.
How do you identify risk mitigation strategies that no longer have the ROI stage when they're ranking it?
It's a good question. It depends on the area of risk. One of the things we're trying to do is constantly update our infrastructure, and especially in our environment, our test arms. It's 4 years old, hasn't really been touched in 4 years, and we've kind of realized, like, this is not going to work going forward. It's becoming a limiting factor for our ability to execute. So that is now getting attention, and that's something that's going to change. In our world at the moment, it kind of happens organically. In other organizations, like when I worked at Capital One, we had a risk register that risk decisions that we had accepted or deferred would occasionally get reviewed. They had an owner, so the owner can go back and review them and say, I really like to get this off my register, right? Can we do something about this, or should I just forget about it? Sure.
So we only have 2 minutes left, so we'll take one last question if you have. If there are no more questions, if you download the app and you go into the schedule and click on this presentation topic, you can rate the presentation. So please do that if you haven't already downloaded the app. Thank you, Chris.
Yeah, thank you. Thank you, everyone. I will say, if anyone has feedback from me specifically, I'd love to hear it. I'd love your thoughts. If you end up working on a system like this or building something like this, I would love for you to share it with me.